Hi everyone, in this video we are going to solve the all the common type of questions that will appear or might appear in your Pure Maths 2. Now this is not a prediction about what your questions will be in tomorrow's exam. This is more like a mere like a practice session, like all the things we did in our entire year. We're just going to solve that only, not anything related that a prediction that okay these questions will come across in your exam paper, because these are actually taken from the recent question paper from 2022 or Jan 23 or this kind of years. So not a prediction over here. Okay, so let's start. This is your binomial expansion. We're starting with binomial expansion first. Okay, this is from the year Jan 2023 and this is question 3 of that paper. So let's start. It says that if x has this expression 2 plus kx by 8 power 7, where k is a non-zero constant, write the first 4 terms in ascending powers of x for the binomial expansion. Now in this case, I can use either that NCR format or the factorial theorem, because both can be used over here as the power is a positive integer, right? As long as the power is a positive integer, you can use any of the formats, NCR or your or your that factorial method. But factorial method has a limitations. I mean, NCR can only be used on this positive integer power when the power is given to you. But actually, NCR has a limitation. You cannot use NCR process with wait 1 minute. Okay, so as I was saying that you can use NCR or factor or factorial theorem in either of that in this case, but I will use that NCR because over here the power is known to you. So we'll start with, they want to find out the 4 terms, right? First 4 term means that 0th term, first term, second term and third term. Over here 0 is also considered as a possible term. So in that case, this is how your working will be, that 0 term, first term, then second term, and then third term. Okay, now you can see they are creating what 4 terms over here. So this is the first 4 terms. For 0 term is 0, so r would be 0. So you have n c0. So basically it's just going to be 7 c0. The value for n is over here 1. A is 2, so 2 to the power of 7, and then kx divided by 8. And then again for the first term, this is going to be 7c1. So we're going to add this with 7c1, 2 to the power of, this will be 6, 7 minus 1 is 6. And now kx over 8, this will have 1 power. And then again for the next term, we're going to have 7c2, 2 to the power of 5. And then kx divided by 8 to the power of 2. And lastly, you have 7c3, 2 to the power of 7 minus 3 is 4, and then kx divided by 8 to the power of 2, and this will all add it together. Right, now after this again you can do the calculations and find out the data. For example, 2 to the power of 7 will give you 128 only, okay, because your entire kx to the power of 8 will have a power of 0. So in that sense, this entire thing will be 1, this entire thing is 1. So you're just getting 128 plus this term over here will give you 56 kx, and then the next term, second term, will give you 21 by 2k square x square. And then again for the third term, you're going to get 35 over 32 k power 3 x power 3 plus dot dot dot. Okay, we're going to do this dot 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 because this is a continuation process. This was supposed to be broken down up to the 7th term, but we're only up to the 8th term, but we're only doing this for the first 4 term because up to this much we are asked to in the question. Now after that it says that given that in the binomial expansion for the fx, the coefficients of x, x square and x cube are the first 3 terms of an arithmetic progression, and find using the algebra the possible values of k. Now they are saying that the first 3 terms are actually one part of an arithmetic progression. For this, remember that for arithmetic progression they have common differences. That means what if you subtract term 2 by term 1, whatever the value that you're going to get is same for that, the difference for term 3 and term 2. That is the case for arithmetic progression. For geometric progression, it would be the division of the two terms, like division of term 2 with term 1, that would be same to with division of term 3 with term 2. I'll just write this down over here. This is like a mini note. So AP, this indicates T2 minus T1 is equals to T3 minus T2. That is what it indicates. For common for arithmetic progression, difference between each term is always same. So they have a common difference, right? Since you get it by subtracting, and subtraction always indicates about difference. So this is about common difference. And then again, if I want to find out that, write a statement for GP. So geometric progression. For geometric progression, this is the division. T2 divided by T1 is equals to T3 divided by T2. That means now they have a common ratio. So the division of the two terms is always similar to the next of the two terms. So this they have now common ratio. So this is like a mini notes. So I will just write this and keep it over here. I would suggest, write these things on top of your copies just for last minute revision. Okay, now we'll go back. Now we can clearly understand that as they were saying that x square, x and x cube, right? So over here T1 term 1 is going to be 56k. Term 2 coefficients of x square, x cube was written, right? That means we're only going to take this number and not that x involved with that. So 21 over 2 x square, and T3 is 35 over 32 x k power 3. These were the three terms. Now it was already stated they are the first three terms of an arithmetic progression. So for arithmetic progression, I know they have a common difference. So using that case of common difference, I can get T2 minus T1, which is 21 over 2 k square minus 56k. That is equivalent, like this will be entirely equal to T3 minus T2. So I'll just write this down over here before in the next line, and this is equivalent to T2 minus T3. So T3 minus T2, which is 35 over 2k power 3 minus 21 over 2k square. Now you can clearly see this completely creates a equation over here, right? And for this equation, I don't have much space, so let's just move on to the next page. Right, okay. Now from this part, I can take k common from the left hand side and from the right hand side. So if I take 1k common, we have 21 by 2k minus 56. And again, if I take 1k common from the right hand side, this will be, I can take actually k square common. So you have 35 over 2k minus 21 over 2. I can clearly understand this k square and k will be cancelled out and will left out with 1k on the right hand side. So basically now you have 21 over 2k minus 56, and then 35 over 2k square. I'll just multiply that k rest with rest of the things we have in the bracket, and 21 over 2k. I can clearly understand at this point, oh wait 1 minute, this was actually 32, not just 2. Right, this was 32. Now from this point I can create a quadratic equation from this. That is basically taking that 21 by 2, 21 by 2 together, and you just have to do LCM over here at this point. So we can just write it like this: 35 by 32 k square plus 21 by 2k plus 21 by 2k minus 56 equals to 0. And from this part, if you do LCM and all these things, the final equation would look like this: 5k square minus 96k plus 256 equals to 0. And from this term, you have to just do the middle term from this point onward. So middle term would be, we can break this down in terms of, we can break this in 16 and 80, right? Yeah. So this will be 5k square, 80k, 16k, and then 256 equals to 0. So this is basically 5k, and then k minus 16, and then 16 is k minus 16, 0. I mean, obviously in your P2 also you have to show this middle term processes, by the way, so you cannot escape that. In that case, you're going to get 5k minus 16 and k minus 16. From this part, you're going to get the two values of k as 16 over 5 or just 16, right? If I zoom out, this is how you're supposed to approach this type of questions with arithmetic progressions or geometric progressions. Another thing to understand is there are a few formulas related to arithmetic and geometric progressions, and we will see those things as we move along the entire process. Okay, another formula we used over here is the formula of NCR, right? So I think we should write that also over here in a box, that for NCR the format is like this: a plus b. Usually the point, the alphabet B has an x associated with that, power n. So this is going to be nc0, a to the power of n, and then bx to the power of 0 plus nc1, then a power n minus 1, bx power 1. Right, always remember this power, this term is always going to be the power of the second term, and this number will be subtracted from the power of the first term. Okay, and that's why we have n minus 1 on top of a, and then again nc2, a power n minus 2, and then bx power 2, and this process will just continue. Okay, so we'll just write that continuation from this point onwards, and this is your formula for NCR. This is also a note, so we will just write in, this is a note. This is your NCR, sorry, 1 minute. This is your NCR format, right? Okay, now we'll move forward to the next question. This is again from your this is again from that binomial expansion, and this is from the year October 2022, so we'll start with that. So this is, yeah, October 2022, and this is question number 2. I think this is also in a similar pattern, so we will start and we can solve this as we go along. So now they have provided you with this fx equals to 2 minus kx to the power of 5, and you need to break this down. Like they says k is a constant, and given that when fx is divided by this, the remainder turns out to be this. So show that the value for k is this. This is basically not entirely a binomial expansion maths. This is a factor remainder theorem combination with binomial expansion. Now they have already stated that when you're going to divide that expression with 4x minus 5, this is what the remainder you're going to get. So you can write an expression using that. For part A, let's just first find out the value for x. For 4x minus 5 equals to 0, the value for x you got would be 5 over 4, right? Using this value for x, you can input this into the fx equation, and that will be equals to 243 over 32, because the remainder was 243 over 32. So now you have f 5 over 4, 2 plus kx, 2 minus kx, so just going to be 2 minus k, 5 over 4, entire thing under power of 5, I think. Yes, entire thing under a power of 5, and this is equals to 243 over 32. I can clearly understand from this point, I'll first have to take this power 5 to the right hand side. So it will be 2 minus 5k by 4 with a 243, 32 with a power of 1 by 5. And later on, I'll just have to make that k subject. So it will be 5k minus 4. So it is 2 minus 243 over 32 with a power of 1 by 5. And then again, I'll just have to make k the subject, which means this will be multiplied with 4, 2 minus 243. Okay, so the value for k in that case, you're getting 2 by 5. We are done with part A. After that, it says that find the first 3 terms in ascending powers of k for the binomial expansion for this, and give this each term in the simplest format. Again, you can use the NCR format. No need to use your factorial theorem, because the power over here is still in positive integer, right? So I would suggest actually to use your NCR formula, because it's just easier to work with. For the first three terms, they indicate about 0th term, 1th term, and 2nd term, right? So yeah, let's start. 2 minus 2 by 5x. For part B then, we'll start from here. This is your 0th term. For 0 term is going to be, it was 5 power. 2 minus 2 by 5, right, 5. So this will be 5c0, 2 to the power of 5, minus 2 by 5x to the power of 0. Plus first term is actually 5c1, 2 to the power of 4, it will be 5 minus 1 is 4, and minus 2 by 5x to the power of 1, plus second term, this will be 5c2, 2 to the power of 3 this time, and minus 2 by 5x to the power of 2, and this will continue. So we'll indicate the continuation with the plus dot dot sign. After this, from this part, we're going to get what 5c1. I mean, this is going to be 32 over here. 2 to the power 5 will be just 32. Then you have 5c1, 2 to the power of 4 with 2 by 5 to the power of 1, which ends up to be 32x over here also. 32x, and then again for the last term, that is going to be 64 over 5 x square. Okay, and this will continue. These are the first three terms of the expansion, and that is it for your part B. We'll move on to part C. Now part C is not related to your concepts about binomial expansion. This is entirely related to your concepts about gradient differentiation. Okay, now they are saying that using the solution to part B and making your method clear, given that the gradient of C at the point where x is equals to 0, and yeah, okay, I mean that's just easy to work with. Now I know for part C, if x, which was originally written as 2 minus 2 over 5 x to the power of 0, that will be broken down into 32 plus 32 x plus 64 over 5 x square, which can be rearranged and written as a quadratic equation, right? We can clearly see this is a quadratic equation. So if you want to find out the gradient, I mean, this is clearly indicating that this is a equation for a positive graph, right? Plus graph, quadratic graph. So I can find out its gradient by differentiating the formula. So equation for your gradient is basically going to be f prime x, and that will be 32 will be entirely vanished as it doesn't have any x associated with that. So 32 it will be, this one becomes 32, and this one actually becomes 128 because 2 comes in front. 64 divided by 5 with x to the power of 1, and eventually we can write this as 32 plus 128 divided by 5x. Now it was already stated we want to find the equation for the curve when the value for x was 0. So we can input the value for x equals to 0. So f prime 0 turns out to be 32, 128 divided by 5, and there was only one x over here beside that 128 by 5 fraction. This entire fraction now becomes 0 at the end. Gradient turns out to be 32. So gradient for that binomial expansion expression when the value for x was 0 is 32, right? Other than that, I don't think there's anything else. Okay, 1 minute. This was supposed to be negative, right? Because this was negative power. So this is negative. This is these values over here is going to be negative. So final gradient that you are getting over here is also negative. So the gradient for the curve when the value for x equals to 0 was negative 32. And that is it for your binomial expansions. Other than that, not that much difficult questions will be asked. So we will start with our next part. That is your trapezium rule. Now in trapezium rule, we basically modify the formula of your trapezium. What was the formula of your trapezium? You should remember that. Trapezium's formula was half a plus b multiplied with height. That is the area for your trapezium. Now, how does the trapezium looks like? Trapezium in most cases looks like this. It will have two parallel sides which are basically named as sides A and B, and this is your height, which is 90 degree, always perpendicular to your parallel sides. And this is your formula which you're going to use to calculate the area under a trapezium. Now over here, we are always going to assume that this area will actually create a trapezium. How can we understand that, or how can we get that trapezium from out of this? We can understand there are 1, 2, 3, 4, 5 data. That means basically we're going to draw 4 trapezium in between them. The ranges are 0 0.1, 1, 0 0.5, 5, 0 0.51, right? So we can consider drawing lines from this part, right? So our main assumption over here is this, that the area in between the lines over here, for example, the area in between the lines over here, this area is an approximate trapezium. Okay, this one is creating an approximate trapezium. Then this one over here is again creating an approximate trapezium. Right, that's why we'll use the trapezium rule. And obviously in your graph, this is not a straight line, we know that, but this is like an approximation method. That's why in a question also, they would ask you to find an estimate area of this kind of graph using that trapezium rule, because this will not give you an exact area, so an estimate or approximate area. So that's why we're like, assuming that, okay, in this case, this is an approximate trapezium. These shaded areas are approximate trapeziums. Okay, now over here, how will I divide the entire cases? Wait 1 minute. These are your negative 0.5 and positive 0.5. Okay, now the chart is already completed for you. In some cases it would not be complete, you would have to complete that, and then again they have to find out the expression within the boundaries of 1 and -1. Now you are not going to integrate it because they want to use the trapezium rule. They want you to use the trapezium rule. In trapezium rule, what happens over here is the format is this basically. Okay, the formal format over here is this. I'm going to consider these y coordinates. Okay, for example, over here we're going to get a y coordinate of y1. We got a y coordinate of y2 from this part, y3 from this part, y4 from this part, and then again y5 from this part. Right, now I can clearly understand over here you have this y1 and y5 over the edges, right? Only these two y coordinates are over the edge, and in between them you have this 2, 3, 4. So the format is half multiplied with half. Inside the brackets, we are going to add y1 plus y5, basically the first one and the last one, and then 2 multiplied with whatever the lengths you have, whatever the y coordinates you have in between the first and last one, you're going to like write those in between this, that y2, y3, and then y4. Okay, this is the formula. Let me just write this down much more clearly and then close the bracket. You can clearly understand the first one and last one is just getting added together, and in between them, whatever lengths they have, they will be twice taken. Like they will be taken twice in your calculation, because this length will also play a role in this area and in this area, right? In the blue area and in the red area. Then again, y3 plays a role in blue and gray. Y4 plays a role in gray and yellow, but only Y5 and Y1 was used once. That's why they're not getting multiplied 2 times. So after this, I will just use the formula. I will just input the values over here. Half multiplied with half. Y1 was 2.287 plus 2.834. This will be multiplied with 4.47 plus 6.719 plus 7.291. Okay, and using this you can calculate the area. If you do this calculation for this process, and that will give you the total calculation. Now some of my students, I specifically ISFA, cannot actually understand how to calculate these things. It's just very confusing for her, so I will go back and write it in a straight line, because her mind cannot process when I do this kind of maths in broken lines. She finds it very difficult, but then again there are many people who finds it little difficult. So I will just modify this. Right now it is all a straight line. You can write exactly like this on your calculator, like pick everything like this on your screen as a calculator, and then give the value for your area under that equation, right, which will be approximately 10.52. Okay, and this was the area for 1 minus 1, and expression was 2 minus 2 over 5 x to the power of 5. This is option A, right? Okay, that is it for trapezium rule. I think we should write this as a formula for your trapezium rule. So just copy this and write this at the very top over here. This is like a notes for trapezium rule. Okay. Now after this, it says that now you need to find out the area for this and this. You can clearly see that formula is quite same. Only there's this plus 2 minus 2 getting added for this. So what you can do over here is, I'll just go back. For part 1, you have fx minus 2 inside a bracket and then fx minus 2. Okay. For part B1, you're getting fx minus 2 with a whole of integration from 1 and minus 1 boundary, which is basically indicating that f minus minus 1 fx is basically subtracted from with a boundary of 2x, right, or 2 over here. So which means 2 becomes obviously 2x in this case. Yes, 2 becomes 2x in this case. Now you have this part is already 10.52. We can already understand this was the expression for part 1, for part A. So I'll just directly write 10.52. And this one, 2 becomes 2x with boundaries of 1 and minus 2. Now when doing integration with boundaries, you do not need to write the plus c over here, right? This is the integration with boundaries, so no need to write that plus c. So this is 10.52, and now it becomes either what, 2 to the power of 1, 2 multiplied with 1 minus 2 multiplied with minus 1, and everything inside a bracket, which is basically when you're going to add this to, like, input this one into that expression once and then again subtract this second part. Like when you're going to add that lower boundary into that, input that lower boundary into the expression, you're going to subtract that from the first equation or from the higher boundary. So you're going to get 10.52. This is 2 and this becomes again plus 2. So 2 plus 2 is 4. This is minus 4 and you're going to left out with 6.52. Right, this is how you're going to do the integration for this part. I mean, you just have to find out the similarities it has with the original equation. And then again for B part 2, the equation was, integration of 1 and minus 1 boundary. And then you have fx minus 2. Now over here, what does this indicate? This indicates that only your x coordinate was just shifted to the right, Nothing else over happens. From your P1 knowledge, I have already stated to all my students from the very start of A-levels that chapter 4 of P1, translation transformation, is the basic for entire A-levels. This one actually indicates what? Horizontal translation. Horizontal translation towards the right. So now if this is a horizontal translation, that means the graph will be exactly same, only it will be shifted 2 units to the right. So if previously the graph was on this part, now the graph will be on this position. There will be no changes in the area. It will still possess the same area, only the graph shifted towards the right. So now over here, area is 10.52. Still no change for the area over here. Only the graph is being shifted to the right. That is the only change. Okay. So yeah, this is it for your integration trapezium rule, area for a trapezium rule. So we'll move on to your next question very quickly. This is again an integration with trapezium rule. Now over here, they have given you informations that these are your coordinates 1, 2, 3, 4, 5. Now this is already clear that your outermost boundary for y is 0 and the outermost boundary for y is again 0. Yeah, and in between them, you have this 1.52, 2.74, 3.12, 3.08. Right, yeah, that is it. It says that a river is being studied at one particular place. The river is 15-meter wide and the depth y meters of the river is measured at a point x meters from one side of the river. The figure shows a plot of the cross-section of the river and the coordinate values for x, y. Use the trapezium rule um, with all the values of y given in figure 1 to estimate the cross-sectional area of the river. This time the value for y is 0 and will start from 0 and end from 0, right? So that y1 and y5, the starting one and the ending one, is going to be 0. We're just going to take these values 1.52, 2.74, 3.12, 3.08, these four coordinates as your equation. Okay, which year is this from? This is from October 2023, very recent paper. So we'll start with this one. Over here, I actually forgot to mention one thing in the first equation. This half over here actually represents the change in x-axis. Okay, for example, you can understand minus half, 1, half, 1, 0. Every point, there's a change in x-axis of 0.5 unit. So I think we should write this in a better way, like change in x-axis over 2. Right, this is how the formula should be written. Now we can go back to your format and we will write down these equations. I'll just write down the equation over here. For area calculation, this is going to be area. You can clearly understand the difference for x-axis is 3, right? 3, 6, 9, 12, 15. So x-axis change is 3. So I can write 3 divided by 2 multiplied with the first one and the last one is 0. So 0 plus 2 multiplied with that 1.52 plus 2.74 plus 3.12 plus 3.08. And if you calculate all these things together, you can get a value of 31.38 meters square, as this was the area, cross-sectional area for a river. So we can now write this is in meters square. That is the value or answer for your part A. Okay, so we'll move on to part B. It says the water in the river modeled as following at a constant speed of 1.5 across the whole of the cross section. Use the model and your answer to part A to estimate the volume of water flowing through this cross section of river each minute. This one is a very important thing. Each minute, giving your answer to 3 significant figures. Okay, now they want you to calculate the volume of water, right? There's actually a formula for this. Formula is volume multiplied with time in seconds gives you speed multiplied with time in second gives you volume. And how can you understand that? You can understand this by using this formula method, that volume is measured in meter cube, right? And speed multiplied with time. Okay, time, wait, that is meter square. Why? Speed multiplied with time multiplied with area, right? How can that be equals to your volume? You have to make them equal according to your unit wise. So speed already has this unit, meters per second, time has second, and area has meter square, which means this second and second gets cancelled out and you're left with what? Meter multiplied with meter square, which will be eventually meter cube. So this is a very important formula, that speed multiplied with time and area always give you the volume of that particular liquid. So this is also a formula. So I'll just write this term in terms of notes. Okay, this is a note. So we will use this to solve your answer for part B. There's nothing else to do, to be honest, for part B. It's just basically the format of using your formula. Nothing other than that. So for the volume, we're going to have area multiplied with speed multiplied with time, which is going to be area is 31.38, speed was 1.5, and time is going to be 60, because it was stating that in each minute, right? Minute means 60 seconds. So if you calculate all these things, you're approximately going to get 2800 meter cube, and that is your volume of water that will flow across that cross sectional of the river in each minute at a speed of 1.5 meters per second square, so meters per second. Okay, so we move on to part C. Assuming the model, state giving a reason for your answer whether your answer to part B is an overestimate or an underestimate of the true volume of water flowing through this section of the river each minute. Now they're saying that if you have calculated the volume 2800, if this is like an excessive value or less than the original value. Overestimate means more than the original value, underestimate means less than the original value. So you have to think about this one thing is that you are approximately thinking all these shapes over here as a trapezium, right? And for the trapezium, you're actually crossing out these sections. You can clearly understand I am, in order to draw a trapezium, right? In order to draw a trapezium, these sections are not taken into part of your consideration. So you are taking these parts as your area or the calculation of area for part A, and you use that to calculate the volume. Then obviously we are eliminating some areas from that cross section. If you're eliminating some area, with that area volume is also eliminated. So this is an underestimation of the original value. So you can write underestimation as the area of trapezium are smaller than the actual cross-sectional area. That would be your final answer for it. For part C, this is an as the area of a trapezium are smaller than the cross-sectional area, sorry. I'll just write CS area, okay? CS means cross-sectional area. Now you cannot write CS. I'm just writing this to save some time. So yeah, this is it for your trapezium rule. We'll move on to your next part. Right, this is from functions and series. We'll start functions and series now. Okay, so for functions and series, this is a combinations of AP, GP, logs, and all those things involved. Now, in this part, the weight of a baby mammal is monitored over a 16-month period, and the weight of that mammal in WKG is given by this equation over here, where you can see the base of the log is A, right? Now, it was also stated that T was within the range of 2 to 18, and where the age of the mammal in months is A is a constant, given that the weight of the mammal was 10 kg when T is equals to 3, and use this information to find out the value for A in 3 decimal places. Okay, now they have given you the value for T and the value for W, 10. So equation was T plus 5 log 4. For part A, you have W is equals to log base A, T plus 5 minus log base 4. We can clearly understand when the bases are similar, and this minus over here actually indicates division, right? But we'll not divide it right away. We'll first input the values of W is equals to 10 and T is equals to 3 into your equation, so which will be 10 log base A 3 plus 5, and then it was subtracted with log base A 4. Now we understand in bases, in logs, in indices, in power formats, minus always indicates division, right? So we can write 10 is equals to log base A. This will actually be 8 divided by 4, which will eventually turn out to be log base A2. So now you have log base A 2 equals to 10. I just inverted that, and there was another formula which we could take this A to the next right hand side, and it would be in the format of 2 is equals to A to the power of 10. If the value for A is to the power of 10, in that case A would be 2 to the power of 1 by 10, which is approximately the same value that was given in your question. This is 1.071777. This is a continuous part, and then we can just keep our answer to 3 decimal places, which will be 1.072, and that is the value for your A over here now. So this was it. Now before we start with this, I think we should I should give you some formulas for log. So these are the formulas for log. That for log base b square, you can take this square in front and write it like this: log base AB, both are same, and it indicates that you can take the power in front of that entire expression. Okay, that is one of the formulas for log. Okay, this is one of the formula. Then the next formula would be your log base AB is equals to 10, so is equals to x, and you can take this base to the other hand, to the right hand side, and it would just be b is equals to a to the power of x. We use this second formula to remove logs from your equation. Then the third one was the addition, like log base AB plus log base AC. Whenever the bases are same, when two logs with similar base are added together, this actually means log base A, B multiplied with C. Right? This addition over here indicates multiplication. Similarly, if you have subtraction in between them, log base AB, log base AC, this indicates log base A, B divided by C. Right, my negative over here indicates subtraction. And then again, there are other formulas like log base AB can actually be written as log base 10b divided by log base 10a. You can actually separate the base and the number in this format, where you keep the number the numerator and you take that base to the denominator. And again, for this case also, they both should have the similar base. So that's why I'm using 10. In this part, when you're actually separating the number from the base by division formula, you can take any number as the base. Okay, I'm taking 10 over here. You can take any number as a base in this situation. Another last one is log base AA. If the base and number turns out to be same number, in that case the final answer should be 1. Log base AA indicates the final solution is 1. So these are what a few formulas for logs, which I think are clearly important for your tomorrow's exam. So I'll just highlight these things. This is your notes. Okay. Now we're done with part A. Now it says for part B, you find an equation for t in terms of w using the value for A. Okay, now we need to eliminate x from that equation. That's what they're actually asking about. So if you want to do that for part B, the original equation was w log base A t plus 5 minus log base A 4, right? I can easily take log base A common from this part. T plus 5 divided by 4, and now I can take this A to the other hand side to make it a power of W, which will be T plus 5 divided by 4 and then A to the power of W. Right, this is how the expression is. The value for A was already calculated in part 1, which was 1.072, so which is going to be, now from this part I'll just make this equation subject. This is multiplied with 4 and this will be subtracted with 5. So you have 4, 1.072 minus 5. And this is your final expression for time, right? This is the equation that you need to make from that part B. After that, if we move on, find the value of t when w equals to 15 and write your answer to 3 significant figures. That is very easy at this point because we have the equation for t, right? Now the value for w is given, which is 1.5. You just have to input this into your equation and that will calculate your value for t. Sorry, not 1.5, time was 15 over here. So in that case, 4 1.072 to the power of 15 minus 5. You can write these things directly on a calculator and this will directly give you answer as 6.35 seconds in 3 significant figure, right? This is your final answer then. For functions in series, these are not that much difficult stuff. Maths, this is it, how we're going to do this. I think the difficult concepts over here is about integration and the circle theorem. Other than that, nothing in P2 is that much extremely hard. So we'll move on to next question. This is again a series. This is mostly an arithmetic series or a next term, finding the next term kind of calculations. This is from your October 2022. So we'll start with this one. Over here they have given an expression that for a series, for a sequence, they are saying that this formula can be used to find out the any value for a term. So they want you to find out the value for A1, A2, A3. What you can do is that for A1, the value for n is 1, right? So in that case, for A1 is just going to be cos square 1 pi by 3. Now, how will you actually represent this cos square on your calculator? Now cos square cannot be written because if you input cos, it will directly like by this cos, right? It will start with a bracket. This actually indicates 1 pi over 3, this entire thing under a square. That's what how you're going to represent this entire expression on your calculator. And again, as this is in terms of pi, I'm not sure if you're supposed to do this in terms of degrees. Do this in terms of radian. Okay, so now you are supposed to do this in terms of radian. Whenever your equation has pi in it, I would suggest do this in terms of radian. So this one actually gives you 1 over 4. And then again for a2, I will write cos 2 pi by 3, and this entire thing will be a square. Similar concept, now I'll just write 2 pi by 3 whole square. This again gives you 1 over 4. Lastly, for a3 over here, for a3 I'm going to write cos 3 pi by 3 and entire thing under a square. But this is obviously going to be just pi, right? Because 3 pi by 3 is eventually just pi. So it will be 1 over here. So these are the values. For a1, that is 1.1 by 4. For a2, it is still 1 by 4. And for a3, the value is 1. And part A is done. Hence, find the exact value for this. Summation of this, and you must make your method clear over here. This is the sigma notation maths, right? Now in this case, what I can already understand is a pattern. The first two terms is going to be 1 by 4, 1 by 4, and the second one is 1. Let's just find out what a4, a5, a6 would have been be. A1 was 1 by 4, a2 was again 1 by 4, a3 was 1. Let's just calculate 1 by a4. I mean, you can calculate that directly on a calculator, so I'm not showing that on screen. This was again 1 by 4. Okay, and then a5, if you calculate that, cos 5 by 5 pi by 3 whole square, that is again 1 by 4. And for a6, this is again going to be what? Cos 2 pi, right? 6 pi by 3 is again 6 cos 2 pi, which is again 1. I can clearly understand there's a pattern over here, right? The first three terms is 1 by 4, 1 by 4. The third term is 1. And that will continue along the entire pathway. So they want you to find the terms from the first term to the fifth term. Okay, this is what sigma notation indicates, that for this expression, we're going to start with n equals to 1 and we'll stop at the fifth term over here. This is the last term we want to calculate. So let's identify how many terms are there. There are actually, in order to find out the number of terms, this is how you calculate it. N minus 50, I mean whatever the values are, 50 minus 1 plus 1, okay, because n1 is also taken into consideration. Over here n1 to n50, actually it stands up to be 50 terms. So we can find out the number of terms in this format. Number of terms. This is always the formula that you are going to use. The highest value, which is the top one, subtract the lowest value, which is the bottom one, plus 1, which is 50 minus 1 in this equation plus 1. That is going to be 50, right? Now, using the number of term, I can find out, wait, I want to find out the total sum for all these things, but over here, the formula is different, right? N plus cos this value, n plus. I can consider as that value as n, so that will be 2a plus. Yeah, this is how they are actually, going to calculate this. They're going to break this entire format into two pieces. One is going to be just 1, and this will be added with the summation of n equals to 1 to 50 for that cos square pi n pi by 3. Right, this is how the entire expression will be divided. For this part only, summation of these arithmetic progression is actually this formula. Let me just write this down. For AP, then again, sum of n terms is actually n divided by 2 to a plus n minus 1 divided by d multiplied with d. Okay, this is a formula for the sum of n terms. Like over here, since you want to find out the summation of the first 50 terms, you cannot obviously do that by summation of 1, 2, 3, 4. You cannot separately add all the values together. This is a formula that you are going to use to find out the summation of the first 50 terms. Now over here, we can clearly understand in this case, the value for a would be 1 because the first term is n equals to 1 where the equation is only 1. So it's just going to be 1 over here. So we are going to write for that first expression is going to be n by 2 divided by 2a plus n minus 1 multiplied with d, and that is going to be 50 because we are calculating 50 terms over there. 2a, the value for first term was 1. In here we have 50 minus 1. Difference is also going to be 1 because in this part, if you calculate it, n equals to 1, n equals to 2, n equals to 3, always the difference over here is 1 for this part of the series. So difference is again 1. If you calculate this, this is what, 25, 2 plus 49, 2 plus 49 is 51, and 51 plus 25, you are getting 1275 from the half of the expression. Now for the rest of the half, for this portion, okay, for this portion over here, I already know a pattern. That is, you have 2 1 by 4 followed by 1 1, right? That is a pattern over here. So try to find out in this format that for the first 3 terms, if you are going to get 2 1 by 4, then how many 1 by 4 will there be for the first 50 terms? Okay, as they have a similar pattern, you can find out that because they do not have any common difference, as you can see. Right, over here the difference is 0, over here the difference is again 3 by 4, then again 3 by 4, 0, 3 by 4. So that is not a common pattern. Whenever they have a fixed pattern like this way, first 2 terms are similar, then the third one is again similar, and that similar pattern is followed along the entire way, you will use this unitary method. That is, for 3 terms, you are getting 2 1 by 4, right? In that case, for 50 terms, you are going to get 2 1 by 4 divided by 3 into 50. Now you can understand that how many 1 by 4 you are going to get in all the first 50 terms. So 50 divided by 3 into 2 into 1 by 4. Wait, no, this is not giving you any process. 1 minute. For the first 3 terms you're getting 2. That means for the first 50, 1 minute. Actually, no, you cannot calculate that. You need to use a different method. For example, over here, the pattern was what? A1, A2, A3, right? This one will have the same value. And then again, you have this A4, A5, A6, which will obviously have the same value. So you can actually understand there in this series, the 3 terms are going to be formed as a group. So you have to understand that how many groups will there be for the 50 terms. So you can understand, for example, I will try to find out that how many groups will there be that is closest to 50. For example, 16 into 3 gives you 48. That means for the first 50 terms, there will be complete 3 pairs of these boxes for at least 16 pair. Okay, there will be like 16 pairs of these kind of boxes for that entire 50 sums, 50 first terms. So this is the first box, this is your second box, and then again for A7, A8, A9, this is your third box, and then again A10, A11, A12, this is again your fourth box, and for A13, A14, A15, this is your fifth box, right? This will continue until you have 16 of these complete boxes. And for these 16 complete boxes, you have already used your 48 terms, right? And as you have used your 48 terms, the next terms will be what? 1 by 4 and 1 by 4 again. Because after the 48th term, that was 1, because the format was what? 1 by 4, 1 by 4 and 1, right? Up to this, you got 48 terms. The next two terms is going to be 1 by 4 and 1 by 4. This is how the format, the pattern is set in this part. So in that case, if you want to find out the summation for this, you just have to use this process, that there are 16 these pairs, 1 by 4, 1 by 4, 1, and there were 2 loose 1 by 4. So 1 by 4 plus 1 by 4, right? If you can calculate these things, you're going to get 49 over 2. So this is again 49 over 2. Finally, your answer would be 2599 over 2. And that is your final statement over here, the summation for all these cases. This is, I think, your part B, right? Yes. Okay, then we're done with this maths. Then we'll move on to your next maths. This is again kind of a similar maths, and this is from January 2023. So we will start. For this part, they have again given you logs at the very top. For logs, you have to simplify that log. I mean, we can easily simplify that log indicating that they have used simple addition over here. For example, 4x plus 2 actually indicates multiply. Right, yeah. You need to solve using the laws of logs, solve this equation. Okay, so you have log base 2. Wait 1 minute. Log base 3, right? Sorry. Log base 3, 4x plus 2 is equals to log base 3, 5x plus 7. From this point, what you can do is that as both of them have the same base, you can just take the bases, like same bases logged together, 4x minus log base 3, 5x plus 7. That will be equivalent to minus 2 now, because we're changing that log to the other hand side. And then again, I can do your subtraction in logs means division. So you have log base 3, 4x, 5x plus 7 is equals to minus 2. So you take that base to the right hand side. So now you have 4x, 5x plus 7 is equals to 3 to the power of negative 2, which is going to be 1 over 9. 1 over 9, this is going to be 1 over 9. So you can just cross multiply it. I'll just write this down for the last state. 1 over 9, and you just cross multiply it. So 9 multiplied with 4 gives you 36x, 5x plus 7. You take that 1 to the right hand side, so you take that 5 to the right hand side, so it becomes 36 minus 1, 5. This is 31x equals to 7. Finally, x would be 7 over 31. And that is your final value for x. Using the logarithmic laws, we calculated this equation, or we solved this equation. This is your solution for part A. After that, they want you to find the summation of log base a to the power of r, this and this. Find y in terms of a, giving your answer in its simplest format. Okay, this is just y to the power of r, and this is whole power r, where r starts with 1, and we need to solve up to the second term over here, not very lengthy. Okay, let's just simplify the expressions separately and then see what we can do over here. So 1 minute, let's just go back to this part. There were two expressions given for part B. One was log r equals to 1 to the power of 2 log base a y r, right? That for this part, the value for r is going to be 1, which is, and this is how it will look like, log base a, log base a y to the power of 1 is just y, and then again for r equals to 2, now you have log base a y square. Similarly, there was another equation which was summation of r equals to 1 to 2, and then now you have log base a y to the power of r. This is a whole power. Now for this whole power, again if you take r equals to 1, this is going to be log base a y to the power of 1, which is just going to remain as log base ay, and then again r equals to 2 is log base ay whole square. This is just log base ay whole square. Okay, we cannot simplify it because this is not the power on top of the number y. This is the power on top of the entire log expression. For this case, now I can write, since the equation was in this format, that summation of r equals to 1 to 2 log base ay power r is equals to summation of r equals to 1 to log base ay to the power of r, right? Summation means what? Addition of the two terms, right? So we're going to write log base ay plus log base ay square is equals to log base ay plus log base ay whole square. We can clearly understand if we take these two together, they will be subtracted with each other, right? So they will just cancel each other out. So there's no point of working that with that. Oh wait, no, 1 minute. Log base y. Yeah, I mean they will just cancel each other out. And another thing, according to our log basics, I can take that power in the front. So using that concept, I will take the 2 log base ay is equals to log base ay whole square. Now what happens after this? You have a whole power square over here, right? Now for this, it actually indicates, let's just assume that log base ay is x. This is let, okay? So that we can assume this much more clearly. So now you have what? 2x is equals to x square. So you take that x square minus 2x in one side and you take 1x common and you have x minus 2 equals to 0. And then what? Either is value for your x is 0 or the value for x is 2. Now you break down that x. X was what? Log base ay. So it was log base ay to the power of 0 or log base ay is equals to 2, which is basically, if you take that a to the right hand side, it will be a to the power of 0, which will eventually be 1, right? Anything to the power of 0 is 1. And the other one is, if you again take that a to the right hand side, it will be a square. That is the two values, either y is 1 or a square. But I don't think we can accept the value for a equals to 1 in the question. If I go back, right, it was already stated that, you know, your value for y has to be greater than 1, and according to that basics we cannot accept this value, the other value we calculated, right? The value for y has to be greater than 1. It was given in the question, so we cannot accept that as the possible answer. So the only answer over here is the value for y is a square, right? That is the only possible answer over here. I hope this was clear for all of you. We will move on to the next question then. This is again from January 2023 and this is for geometric series. I have actually compiled this entire file in such a way so that it covers, almost all the maths from your specifications, which you can use before your exams at this point. So this is for GP. For GP, it has this geometric series of the first term A and common ratio R. As I've already stated, for geometric progression, they have different common ratio together, right? Division of the second term with the first term is equals to division of the third term and second term. And from this part also, you have equations involved like summation of R terms, summations of N terms, like similar to the one we did for AP. Like summation of N terms for GP is actually going to be, okay, now these are the formulas for sum of n terms for arithmetic progression. This one has to be used when the value for your ratio, common ratio, is less than 1. And this one has to be used when the value for your common ratio is greater than 1. Now, in this case, they are saying that there is an arithmetic series or sequence with the first term a and common ratio r, where r is greater than 0. That means this statement is using, right? It is greater than 0, but it was not stated anything that if it is less than or greater than 1. So it was stated the third term was 20, fifth term was 12.8. We need to show that the r is 0.8. Okay. Now over here, for every individual term, there are equations for AP and GP. Let me just draw this over here. I'll just extend it a little bit. For as we're doing this for GP, let's just find out that how would you find out the expression for every individual term. For example, Tn actually is calculated as AR n minus 1. Okay, that is for GP. And if you were calculating this for AP, then the equation would be Tn A plus n minus 1 D, and that is for AP. Okay. Now we are in GP, so we'll use this expression as we already have the value for T3. T3 is 20. It can be expressed as AR 3 minus 1 is going to be 2. n represents the number of term, right? So over here ARn minus 1 is going to be 3 minus 1, so r squared 20, and then we have T5 as 12.8, which is AR power 4 12.8. Now using this is equation 1, this is equation 2. In most of the geometric progression cases, you do not actually substitute over here. Over here it's easier to divide these things clearly. So I'm going to start doing T5 divided by T3, which is going to be A power 4, this is going to be 12.8 divided by 20, and then again on the left hand side you have A power 4, AR power 4, AR power 2, 12.8 divided by 20. From this part A gets cancelled out, and A r power 4 minus power 2 is going to be just r power 2. So you have r square 12.8 divided by 20. For the last part, r would actually be 12.8 divided by 20, everything under a root. If you calculate that, you are going to get the value for r as 0.8, and that was the value that was asked to be shown on your question, and we have did that. So that is it for the final value for r. Now it says that find the value for a. Since I already have the value for r, I can input that r into any of the equation to get the value for a, right? So this is your part A. For part B, I am using T3 as 20, which is going to be a. R is 0.8 square 20, that is 20, 0.8 power 2. So you get the value for a in that case as 31.25. So this is the final value for a. After this again you have given that the sum of the first n terms of the sequence is greater than 156. We need to find out the smallest value for n. Okay, this is for greater than, right? Which means the sum of n terms is greater than 156. Given that the sum of n terms of the sequence is greater than 156, right? This is the inequality that was stated from this expression, and now we'll start working out. As we can already understand, the value for r is less than 1 for this specific equation. This is the equation for sum of n terms that we have to use, and for part C we will actually start using this, that sum of n terms greater than 156, which is going to be what? A 1 minus r to the power of n divided by 1 minus r greater than 156. Now we do not know the value for n, but we know that the value for a and r is 131.25, 0.8 respectively. So we'll input the values for those into an equation. One minus 0.8 greater than 156. 1 minus 0.8 is 0.2, and if you divide that with 31.25, you're going to get, like, if from this part I'm just going to make 0.8 power n and 156. This entire expression is 0.2 gets multiplied with the 1.6 on the right hand side, and then again gets divided with that 31.25, because this was in the multiplied format in the left side. So when you take that to the right hand side, obviously it gets divided. So now again you have 0.8 power n 1 minus 156 into 0.2 divided by 31.25. So if you just calculate this entire expression, 156 into 0.2 divided by 31.25, you are going to get 1 over 625. Now problem is that I want to calculate the value for n, right? So I will actually multiply both sides with log base 10. Then what happens? Now you have log, there's no point of writing base 10 because base 10 is the basic format. So you can just not skip, you can just skip writing that also over here. 625. What you can do again is that you can take this n in the front, so it will be n multiplied with log 0.8 greater than log 1 over 625, which is now going to be n greater than, since it was in multiplied format, you change this, it will be log 1 divided by 625 divided by log 0.8. Okay, so if you calculate this, you're actually getting n as 28.85, which indicates that the value for n should be greater than 28.85, right? So it could be 29, 30, 31, 32. As in a question, they were asking about the smallest value, right? Obviously, n over here turns out to be greater than 28.85 indicates it could be 29, 30, 31, 32, all the other cases, right? So according to that range, the smallest value over here is this 2.29. So in that case, the smallest value for n over here is going to be 29 because other values of n are certainly greater than of that. So this is the working for your questions for this geometric progression. We will now move on to your next part, this one. Okay. Uh, in a theater, in a large theater, there are n rows of seats where n is a constant and the number of seats in the first row is a, where a is again a constant. Each subsequent row, there are 4 more seats than the previous row. That means what? If there are n rows of seats, for the first row, they have a number of seats. In the second row, they will have a plus 4 number of seats. In the second row, they will have a plus 4 number of seats, right? That is the pattern. For n1 first row, you have a seats. For n2 second row, you have a plus 4 seats. For n3, you have a plus 4 seats. For n4, you have a plus 4 plus 4 plus 4 seats. Basically, they are actually indicating this is a common ratio, common difference maths. For common difference maths, this is an arithmetic progression maths, right? You can write this also in terms of a plus d, a plus n minus 1 d, which is going to be 2d, a plus n minus 1 d, which is going to be 3d over here, right? And this is the equation for your arithmetic progression. Now it was already stated that in the second row you have a plus 4 seats and in the third row you have a plus 8 seats, and the number of seats in each row form an arithmetic sequence given that the total number of seats in the first rows is 360. Given that the total number of seats in the first 10 rows over here, it's total number of seats, which means they are actually indicating about Sn over here, right? S10 over here. Now you need to find out the value for A, okay? Let's just write this. T1 is A, T2 is A plus 4, T3 is A plus 8. This was already given. From this part, you can understand common difference is 4, right? First term is A. That means from S10, which was already given as 360, you can write this as 10 by 2, 2a plus n minus 1 is going to be 9, 9d is 4, and this is equals to 360. Remember, I'm using the formula n by 2, 2a plus n minus 1d, and that is your expression for the formula that I'm using over here. Okay, now for this part, this is going to be 5, 2a plus 36, 360. From this part, I can clearly understand. I just have to make A the subject of this formula. So this is going to be 360 over 5 minus 36. And this entire thing has to be divided by a further 2. So which will be 360 by 5 minus 36 divided by 2. And the value for A turns out to be 18 over here. Okay. This is the working for part A. We calculated the value for A. After this, it says that the total number of seats in a row in n rows is given by 2, 1, 4, 6, and we need to show this equation. We can show that. Now we have the value for A as 18, the value for common difference as 4, and we need to find out Sn, right, which is n divided by 2, 2a plus n minus 1, 4, which is going to be n divided by 2. This is what? 2a plus 4n minus 4. That is, right, so we'll input that value for a into the equation as 18, which makes it 36. 36 minus 4 is going to be 32. So from that part, n divided by 2, it's going to be 32 plus 4n. From that situation again, if I take 2 common, now you have n divided by 2 multiplied with 2, 16 plus 2n. This 2 gets cancelled out and now you have 16n plus 2n square. Another thing, if you go back to the very top, it was stated the value for this entire expression is going to be 2146. So this entire expression is actually equals to 2146, 2146, 2146, and then 2146, 2146, and 2146. If you take all of these numbers in one side, minus 2146, and take like divide entire expression by 2, then this becomes n square 18n, and 2146 divided by 2 should give you 1072. 1 minute. Yeah, 1073. Sorry, 1073. Yeah, so minus 1073 equals to 0. And that was the expression which was about to be shown in your part B. We have clearly expressed that, represented that. So this is our working for part B. For part C again, if you go back, now they want you, hence state the number of rows of the seats in the theater and the maximum number of seats in any one row. Okay. Hence state the number of given that the it was also given also that the total number of seats in the n rows is this. Hmm. So if we can have n over here was also the total number of seats, right? In large theater there were actually n number of seats. N was actually the total number of seats in that case. So in order to calculate the value for n, that will give you the number of seats, maximum seats in that theater, total number of seats in that theater, right? So for part C, actually, we have to first calculate the value for n. So let's just, without wasting your time, let's just calculate this. Now I will skip middle term over here, but you obviously have to do middle term for this part. 1, 8, 10, 73. That is going to be 29 and 37, negative 37. Okay. If you do middle term, the value for n turns out to be negative 37 or 29, which means that this one is incorrect. Number of seats cannot be negative. That means, wait, this turned out to be 29. And 1 minute. Given also that the total number of seats in the n rows, sorry, this one gives you that there are in the n rows there are 2, 1, 4, 6 seats. Okay, now we got the value for n as 29, right? So now we know for the first one, the number of rows of seats in that theater is actually 29. And now they want you to find out that how many seats were there in total of that 29 seats. You can calculate that by calculate the Tn over here. Okay, they want the maximum. Okay, they do not want to find out the total. Total is already given that from that first row to 29th row, in total, there are 2,146 seats, but they want you to find out that exactly at the 29th row, how many seats were there. So they want to find out the Tn, T29. For that T29, this is going to be A plus n minus 1d. For the value for A, you got 18. N minus 1 this time is going to be 28. 29 minus 1, 28. 28 multiplied with your common difference was 4. So if we calculate that, that should be 130. So in that case, at the 29th row, there are 130 seats. So yeah, with this, our ABC ends. There is another function maths. Let me see 1 minute. Then we have differentiation. Okay, let's just finish this one. Okay, the height of a river above a fixed point on a river bed was monitored over a 7-day period. The height of the river h meters t days after monitoring began. This is the expression root t over 20, 20 plus 60, t square plus 17. And given that h has stationary value when t is equals to a. Stationary value. What does this indicate? This indicates differentiation of this equation was 0 when t is equals to a. The stationary value indicates that as this equation is in terms of t, so differentiation will be th over dh over dt. Right, this is equals to 0 when t is equals to a. And using this knowledge, that's why they're using calculus to show that a satisfy this equation. You have root t 20, 20, 60, 2 square plus 17. You just have to simplify that first. You cannot work out with this format. So you have h root t over 20, and then 20 plus 6t minus t square plus 17, which is what? 20 root t by 20 plus 6t root t over 20 minus t square multiplied with root t over 20 plus 17. That will approximately be t to the power of half. I like to write everything in terms of power when I know I have to differentiate this. So 6 by 20 is actually 3. Wait, sorry, 6 by 20 is actually 3 by 10. 3 by 10, and this t power 1 and t power half is actually t power 1.5. So t power 3 by 2 minus this is going to be 1 over 20. 2 plus 0.5 is 2.5. So t power 5 over 2 plus 17. From this part, if I want to differentiate is dh dt, this will be half t to the power of minus half, because half minus 1 is half. Half minus 1 minus half, sorry, half minus 1. Half minus 1 is negative half, right? This is a negative sign, by the way. And then again you have 3 by 2 in front with multiplied with 3 by 10, and then 3 by 2 minus 1 is just going to be positive half. And then again this 5 by 2 comes in front, gets multiplied with that 1 by 20, and then you have 5 by 2 minus 1 gives you 3 by 2. The 17 will be entirely vanished because it doesn't have any x involved or t involved with that. So now you have half t to the power of negative half, and then this is 3 by 2 multiplied with 3 by 10. This is 9 by 20 t power half, and then this one is 5 by 2 1 by 20. This is again 1 by 8 t power 3 by 2. From this situation, one thing I can notice is that we have half common over here, right? So if you have half common, uh, if you go back to your question again, sorry, 1 minute. 5 t square minus 18t minus 20. This is the format. You have to simplify this your equation in. So let's just do LCM over here first. 2, 20 and 8. So 2, 8, 20. If you take 2, this is 1, 4, 10. Then again 2, 1, 2, 5. So 2, 2, 2, 8 into 5 is going to be 40. Over here, the overall LCM, 2 into 2 into 2 into 5. Yeah, this is 40. So in that case, we can write this as 40 t power half. This is going to be what? 40 by 2 is going to be 20 t power half, negative half, and then 40 by 20 is going to be 18 t power half, and then again you have 40 by 8 is just 5 t power 3 by 2. From this part onward, I can do one thing. I can take half common over here. So if I take half common, this will actually be 1 minute, 1.5 minus 0.5. No, I cannot take half common because I have to make that 1.5 as a square. Okay, so wait 1 minute. The format was 5a square 18a minus 20, right? Hmm. Hmm. Wait 1 minute. I don't think we need to do a square over here. Yes, over here for the next line, this was in fractions, right? So we can write this as actually root t plus 18 root t minus 5t to the power of, this is 3 by 2, right? And this entire thing is obviously divided by 40, but let's not think about it because I know at this point your dh by dt was 0, right? So I'll just write this as entirely 0. So that means the 40 on the right hand side will be 0 in that case. So we're just going to focus on that expression. So 20 root t, if you do that LCM now again, that over here the entire LCM is going to be root t. Okay, let me just write this statement again. 20 root t plus 18 root t minus 5t power 3 by 2, 0. And now I can make the total LCM as root t, right? Root half, which is 20. That means 18 root t multiplied with root t and 15t to the power of 3 by 2 multiplied of root t, 0. You again take that root t to the right hand side, so it will be vanished. And after that, you have 20 plus 18t minus 5t square, 0. Now, I already know this was only possible for when the value for t was a. So, I'll just substitute that equation now. So, which will make it 5a square minus 18a minus 20 equals to 0, because I want to make that a square positive. And this is the final format. After this, again, if we go back, now you need to find out the value for a, giving you answer to 3 decimal places. That means we can clearly understand at this point you have to use your formula method for the middle term factorization. So that will be 18 plus minus 5 square minus 2, 5 minus 20 divided by 2, 5. Okay, if you just calculate that using a calculator, 5 minus 18 minus 20, now you have 4.49 and then 0.98, 0.89 with a negative. Okay, these are the two values for a. Okay, now after this again, use further calculation to prove that h is maximum at this value for a. Okay, I mean at maximum point I know double differentiation is equals to, like, double differentiation should be negative. For example, the value for a you found out was 4.49, right? If you go back to your part, okay, the A river over here represents what? The height of a river above a fixed point over a river bed was monitored over the 7-day period. A represents time, right? Time cannot be negative. So you're only accepting that 4.49 as a possible value for A. And using that, I will double differentiate the equation and then calculate that if for this value, if the expression is positive or negative. Okay. So far we know dH by dt is what? This one, 5t square, 18t, 20. So 20 plus 18t minus 5t square. So d square h dt square, double differentiation will be just 18 minus 10t, where the value for t is going to be now 4.49. So 18 minus 10, 4.49 is actually going to be 18 minus 10, 4.49 is negative 26.9. For this negative 26.9, always remember, if the double differentiated equation comes out to be negative, that means obviously at this point, this was actually for the maximum coordinate, right? If I go back to your question, we need to prove that, and we did prove that, right? So we can write that yes, this is for the maximum coordinate. For differentiation, again, we have an entire series of videos involved. So I would suggest go through that recording. And if you have any problem, please try to suggest consulting with me. So we will move on to your next part, which is basically, I think, trigonometric. The next part will be integration area. Going to solve the differentiation worksheets. These are from paper like Pure Maths 2. From A levels. Okay, this is P2 of A levels. So we'll start. I think on your book this is chapter 8. The worksheet is entirely compiled with your question papers. They have questions from the recent paper and also from the old papers. This is like a combination. Okay, I think this entire paper will have like 10 questions, 10 to 11 questions over here, and we're going to solve each question within this video. So let's start. Now problem is I do not have space over here to solve these videos, like solve these questions. So I'll be taking parts of this question and solving in the other PDF. Okay, Now in question 1, it says that this structure, which we can clearly identify, this portion is a rectangle and the other portion is a semicircle. Right, so I'll just label it with alphabets for my easiness of the explanation. So this is point A, B, C, D and E. So we can clearly understand ABCE is a rectangle, whereas your CDE is a semicircle. And obviously the 2x is going to be half of that, like the radius of the semicircle is going to be just x meters, right? Okay, now again it shows that figure 3 over here shows the plan of a stage in the shape of a rectangle joined with a semicircle. The length of the rectangle is 2x meters, wide is y meters, and the diameter of the semicircle is also 2x meters, and the perimeter of this entire thing is given as 80 meter. Now it says that show that the area of that a meter square on the stage is given by this. Okay, area for this we can clearly understand. We just have to use the formulas for the rectangle and semicircle. Now I do not have much space, so I need to use a different page. 1 minute. Okay, this is like the solving for that file, so I'm going to consider this. Wait 1 minute, do I have that file open? Okay, so this is question 1. Now I'll just keep a heads up for that statement which we were trying to solve over here. So I'll just take a picture of this and then solve it. Okay, now I can clearly understand the area of a rectangle is going to be what, 2x multiplied with y, and the semicircle is going to be just pi r, right, because it is half of a circle. So for this case, area is going to be rectangle plus semicircle. For rectangle you have 2xy plus just pi x, because radius over here for the semicircle is x, so pi x. Okay, the problem is there is over here in the given equation for your area, it doesn't have any y involved, right? But on your equation you have this y. What this means that you have to use this perimeter over here to find out a second equation in terms of y. So this is your equation 1. Okay, and then again I'm going to find out the second equation in terms of y over here, which is going to be I already know the perimeter over here is going to be what, 2xy, y, and this half circumference of this semicircle. So for this perimeter, I'm going to write it down as 2y plus 2x plus the circumference is what? Sorry, what? 1 minute. We were trying to find out the area over here, right? Sorry, I forgot. Over here it's going to be half pi r square. So in this case we're going to get half pi x square. For the circumference, now you're going to get right that for total circumference of a circle it is 2 pi r. For half of that we have to divide this with 2. 2 gets cancelled out, you just get pi r for the circumference, which means now you can write just pi x is equals to 80, because we already know the perimeter was equals to 80. Now we're going to just make y the subject of this equation, which is going to look like y 80 minus pi x minus 2x. This entire thing will be divided by 2, right? 80 minus pi x minus 2x. Yeah, this is what your second equation would look like, and obviously after this I'm going to substitute the second equation into the first equation. This is how the equation looks like. Substitute equation 2 into equation 1, which is now going to be 2xy half pi x square. Area, previously you got 2xy plus half pi x square, and instead of y we're going to now introduce it to that equation, which was 80 minus pi x minus 2x over 2 plus half pi x square, which certainly means these two gets cancelled out, and this entire expression will then be multiplied with x again. So now you have 80x minus pi x square minus 2x plus half pi x square, which again this and this can be cancelled out together or added together. Minus pi x square plus half pi x square gives you minus half pi x square. So it's going to be 80 pi minus half pi x square minus 2x. Now again, if you go back, your expression was written as over here it's going to get x squared also, because x will get multiplied with 2x, right? We're just going to get x over here common, so which is going to be 80 minus, if you take x square common, but at the end, this is how it's going to look like. 2x square is just going to be positive 2, and then again half pi x square is going to be positive pi by 2. We can write it down like this, as we have took minus over here common in the front of this bracket, right? So everything will be multiplied with the minus, and everything will return back to its minus signs. So this is how the expression would look like, and this is what the expression was supposed to look like according to your equation 2, right? 80x minus bracket 2 plus pi by 2, entire thing with the combination of pi square. So this is approved maths. We have did this completely fine. Now we're going to move on to the second part. Like all these things, area, perimeter, then the substitution working, all these things will get you the 4 marks. We're going to move on to the next questions. Use calculus to find the value of x at which a has a stationary value. Okay, now for this stationary value, I know that at stationary value, at turning point, at maximum point, at minimum point, the differentiation for that equation is going to be equals to 0, right? So they wanted to find out the value for x when area is equals to 0, when area is stationary, which means that differentiation of this area with respect to x is going to be 0 for this stationary point. So it's quite easy at this part. For part B, we're going to write that at A's stationary point, dA by dx is supposed to be 0. Okay, so in that case, differentiation for this equation is going to be 0. It's better to use in this format than use this format, right? Because it is like in a product format, you have to simplify that with the brackets and then get the equation, right? So it's better to write it in this way. Like a is going to be 80x minus half pi x square minus 2x square, and then I'm going to find out the differentiation dy by dx. 80 will be just 80, half multiplied with 2 is going to be 1, so you get pi x, and this is going to be minus 4x, right? This entire equation will be equals to 0, which means then we can take x common over here also, which is 80 minus x pi plus 4 equals to 0. At the end, you can write x pi plus 4 equals to 80, and x is eventually 80 over pi plus 4. Now in the question, it was never stated that you have to find the answer in decimals. I will actually like to keep my answer over here like this, because it gives you the most accurate value, right? So I'll think of it as the final answer, 80 over pi plus 4. That is the final answer for your x. This is the value for your x you get when a is at a stationary point. That means the differentiation with respect to x will be 0 at this situation, right? And using that situation, you got the value for x over here. Okay, now moving on to your next question, part C. For part C, it says that prove the value for x when you found in part B gives you the maximum value for a. Okay, now in order to prove that, this means basically you need to find out the nature of this value for x that you got, right? Because whenever your differentiated equation is equals to 0, that could be either this point is a maximum, this point is a minimum. Okay, you need to identify that if this is for the maximum or minimum. Okay, so I'll just draw a very, very simple graph to explain you this. For example, you might also have a quadratic equation to work with, right? And not quadratic, cubic equation to work with in some cases. And in cases for cubic equations, what happens is that in cubic equations they have this both points involved, right? This is the maximum, this is the minimum. Now how can you identify, like over here for this kind of situations, when you're going to differentiate the differentiate the equation and consider the differentiated value equals to 0, you're going to end up getting two values for x. Now how can you identify which one will be the positive and which one will be the negative? You can identify the nature of the roots by double differentiating the equation. Okay, so first process first, you need to double differentiate the equation. After double differentiating the equation, whatever the value that you got, okay, from the first differentiation, you're going to input that value of x into the double differentiated equation. And if under using that value for x you got with the first differentiation, if your second differentiated equation with that value for x comes out to be positive, then it is for the minimum point. Then that value for x was for the x coordinate of the minimum point. And if using the x coordinate of the first differentiation gives you a negative double differentiation value, then it was for the maximum point, right? This is how you're going to identify the nature over here. Okay, so which means I'll just erase this a little bit, because or I think I should write a flow chart over here. In order to find out the nature of roots, what you do, first thing over here you do is that in order to find out the nature of roots, first thing you do is that dy by dx is equals to 0, and calculate the value of x. Okay, using the differentiation dy by dx equals to 0, you calculate the value of x. Okay, and after this, using the value of x, you're going to input this x into the equation for your double differentiations. Okay, use or input if now you get the double differentiation equation positive, this is for the minimum point, and if you get, using the value for x after inputting that into a double differentiation equation, if you get double differentiation equation as negative, then this was for your maximum point. Okay, now remember in your question part C, they were actually asking to find out that how can you understand the value that you got for x, which was 80 pi plus 4, is actually the minimum x coordinate for this situation, sorry, maximum x coordinate for this equation. You can identify that by following these procedures, right? So the first thing first we're going to do over here, we already know when dA over dx was 0, the value for x you got was 80 pi plus 4, right? This is the value that you got for x when the differentiation or when area was at stationary. In order to find out the nature, you have to first find out the expression for the double differentiation. Okay, now what was the value for the normal differentiation you got? 80 minus pi x minus 4. Okay, d square y dx square, originally this equation was 80 minus pi x minus 4x, right? Obviously if you double differentiate it, 80 will be entirely vanished from the equation, pi x will become negative pi, and negative 4x will just become negative 4, right? In some cases there are situations also like this when the double differentiated equation does not have any x. In that case it's just easier for you, you do not need to now input anything into the equation, right? You can just now find out, we can clearly see this is going to be a negative answer, right? Which is what, negative 3.142 negative 4, this is approximately going to be negative 7. I can clearly understand that from this equation already. Minus 7 minus 4, yes, minus pi minus 4 is indeed giving you minus 7.142. so you get the double differentiation value as negative. So if you're getting the value for double differentiation as negative, this certainly identifies your value for x as 80 pi by pi plus 4 as the x, maximum x coordinate for this situation. You can now see this is double differentiation is negative, therefore x 80 pi plus 4 is indeed for the maximum x coordinate. So maximum, right? Since you got negative double differentiation, so this is for a maximum x coordinate, which is correct. Now after this, they want to find out that what would be the value for the area, right, in this situation. Like obviously your graph is at the stationary point. Like for example over here, this is how they're actually referring to this situation. They have a in the y-axis and x in the x-axis. Now for this stationary point, right, you got the x coordinate as 80 pi plus 4. But what about the y coordinate, right? On the y coordinate, they must have a value. Obviously, at this point, your dA by dx was 0. Differentiation for this situation was 0, but what about the y coordinate for this case? Or you can say the a coordinate for this case, right? So you're just going to input that value for x into the original equation for your area. For part D, you just want to find out the value for area when x equals to this 80 pi plus 4. So for area, it was, I think, 80x minus pi, sorry, I think it was 2 plus pi by 2 with x square. Right, now and in every cases, we're going to write 80 pi plus 4, then 2 plus pi by 2 multiplied with 80 pi plus 4 square. We're going to input all these things on a calculator and find out the value over here for the last part, for the area when a was this value. Okay, which is going to be 80 divided by pi plus 4 and minus 2 plus pi by 2. The second gets multiplied with 80 pi plus 4 is whole square bracket. But you approximately get 488.079. We're going to keep our answer to 3 significant figures. So you get 448 meters square, right? Because area was measured in meters square. So 448 meters square. This is the final answer. I hope this was all clear to all of you. This is how you're going to do the procedures. Nothing else than this. Thank you. We're going to move on to the next question then. Right, in differentiation for pure maths P2, it's quite repetitive. It doesn't change that much, and that's not that much stuff also, I would say. So wait 1 minute. I'll again take a screenshot of this second question and then do it on the other file. Question 2. Now it says that you have this cubic equation. You need to find out the differentiation of this, which we can clearly understand. 3 will come in front, multiplied with 2 becomes 6, and 3 minus 1 gives you square. 5 comes in front, multiplied with 5 gets you 10, and 2 minus 1 is just 1. And then you have 4 to the power of 4x to the power of 1. 4 gets multiplied with 1, so you get just minus 4. Right, this is how the expression would look like, and 2 will entirely vanish because it doesn't have any x, and differentiation over here was with respect to x, right? So it will get vanished. Okay, and again it says that find using the result from part A, find the coordinates of the turning point. As we have already stated that in turning points, right, in turning points, stationary points, maximum point, minimum point, in all these cases your dy over dx is equals to 0. So we're going to use that concept over here. For part B, in this case, dy is equals to dy by dx is equals to 0, which is 6x square minus 10x minus 4 equals to 0, which is eventually going to be, I'm going to split the 6 and 6x square, 6x, 4x, 4, 0. Wait 1 minute. 6 minus 10 minus 4, 2 and 1 by 3. Okay, then I think you are supposed to split this using 12 and right, 12 and 2. So this is going to be 12 Okay, this is going to be 12 and this is going to be positive 2, and now it will give you the perfect answer, which is x minus 2 plus 2 is x minus 2, 0, 6x plus 2 and x minus 2, 0. That means from the first part we're going to get minus 1 by 3, and from the second part we're going to get 2. Okay, so 1 by 3 and 2, these are the values for x. Okay, after this, we kind of need to find out the coordinates, right? For for the coordinates we also need the y coordinate, right? These are only the x coordinates for the turning points. In order to find out the y coordinate, I'll input these values for x into the original equation for y. So for the original equation of y was 2x cubed minus 5x square minus 4x plus 2. So we're going to get, when x equals to minus 1 by 3, y is going to be 2 minus 1 by 3 square, cube, minus 5 minus 1 by 3 square minus 4 minus 1 by 3 plus 2, and this entire expression will again be included with a positive 2, right? Because other value for x was positive 2 for the second turning point equation. So you actually get 73 over 27 for this part. So for the first case, the equation is going to be 73 over 27. And then again, if you do the same equation with 2 again, you're going to get minus 10. Right, so the coordinates for the turning points are first one is minus 1 over 3 and 73 over 27, and the second one is 2 with minus 10. Okay, now in part C, they wanted to find out the double differentiated equation, which we can again do over here again. 2 comes in front, so becomes 12x and 10, right? Yeah, this is the double differentiation equation. Now you need to find out the nature of the roots, right? Nature of the turning points, which we explained previously. We're going to substitute the values in the double differentiated equation now, because now your double differentiated equation comes with x, right? In the previous part, when in the previous question, when we did double differentiation, the question rearranged in such a way that it doesn't have any x for the double differentiation equation, right? So we didn't actually have to input anything on that part. But in this second question, they have this x over here for the double differentiated equation. Now we have to input the value for x into this equation. So I'm going to write it down over here that for d square y dx square was 12x minus 10. So when x is actually negative 1 over 3, this d square y dx square is 12 minus 1 over 3 minus 10, and then again when x equals to 2, this d square y dx square is 12, 2 minus 10, which is going to be 12 minus 1 over 3 plus 10, that is positive 6, which means this one must be the x coordinate for a minimum turning point. And if I do the same thing, wait 1 minute, I think, sorry, minus 1 over 3 minus 10, right? Sorry, I made a mistake. This one was negative 14. Okay, and if I did the same thing with positive 2, now I get positive 14, which clearly distinguishes that this minus negative 1 by 3 with 73 over 27 is the maximum turning point, right? So this is the maximum, and the other one, this is the minimum, which is 2 with minus 10. Okay, in order to identify the nature of your roots, we only need nature of your turning points. We actually only need the x coordinates, right? The y coordinates are not needed. Okay, so yeah, this is it. This is how we're going to solve most of the maths in this chapter. Actually, for differentiation, they do not have that much variability. Questions would differ. I mean, the equations would differ every time, but over the time, the process is all the same, right? You can clearly see minimum point, find out the y coordinate, identify the nature. This is the same procedure for all the equations. Okay, we're going to do another maths, which is this one. Okay, now again in question 3, it says that a diesel lorry is driven from Birmingham to Bury at a steady speed of v kilometers per hour. The total cost of the journey in pound is given by this equation, and find the value for v for which c is minimum. This is the same procedure. You have to find out the differentiation for c, that would be equal to 0, and then you have to find out the value for v, which is quite typical at this point. We can obviously calculate that. For part A, I'll write c in terms of power because I cannot differentiate when these fractions get involved. So now we have 1400 v to the power of negative 1 plus 2 by 7v, which is going to be dc by dv. That's negative 1400, right? Because the negative 1 comes in front, gets multiplied with 1400, so it eventually becomes negative 1400. So with the power of negative minus 2, now minus 2 because we're going to subtract minus 1 from 1, so eventually we're going to get minus 2, and this one will be 2 by 7. Now this was a case for when c was minimum, which means that it was already given to you that dc by dv was 0. So this entire thing, differentiated equation, will be equals to 0. I'll write this over here as 1400 over v square is equals to negative 2 by 7, right? And I'll just make v square the subject, which is just going to be 1400 negative 2 over 7, and this entire thing will be inside a root, right? If you take that square on top of v to the left and to the right hand side, this is how it will look like. 1400 2 over 7, sorry, you get 70. The value for v when dc by dv, differentiation for when c is at a minimum point, is 70. That means over here the minimum velocity, the speed of v kilometers per hour, the minimum velocity that can be achieved with the minimum for the minimum c is 70. Now they want you to find out the double differentiation and hence verify that this is indeed the minimum value. Okay, similar work. For part B, d square c and then dv square is going to be that minus 2 will come in front and get multiplied with 1400. So minus 1400 with minus 2 will be 2800. So 2800 v to the power of minus 3 this time, and 2 by 7 will entirely vanish. At this point, I'm going to input the 70 over here in this equation to identify if I get positive or negative values for the double differentiation. So that's 2800 70 to the power of negative 3, which is 2 over 245. That is actually a positive value, 2 over 245, and this is a positive value. And whenever your double differentiation comes out to be positive, obviously this means that this point that you have included in the equation must be for a minimum point, right? So finally we have proved that since d square c dv square is positive for v is equals to 70, c is at minimum. But this is not the maximum, this is indeed the minimum coordinate then. Okay, and after this they want you to find out the minimum total cost of the journey. That means using that c, you're going to input that in the original equation and just find out the value for c. 1400 over v, 2v by 7. Okay, for part C it's going to be C 1400 over 70 plus 2v it was, right? So 270 over 7. That will give you the final answer, which is 1400 over 70 plus 270 over 7, and you're going to get 40. Now this is the minimum cost, right? Okay, now like every question is kind of in a similar pattern, so this is it. I'm going to stop the video over here. Thank you for watching. This is the differentiation for P2 Pure Maths 2 A levels at Excel. Thank you for watching. Bye bye. We will start with integration now. For the integration process, it is somewhat related to differentiation and integration. So let's start with this question. This is from October 2023. So it says that figure 3 shows a sketch of the curve with equation this one, and find using calculus the range of values of x for which y is increasing over here. Okay, so in this situation, what this indicates is that y is increasing means that in this situation, your differentiation is not equals to 0. This time for y is increasing, it indicates your differentiation would be greater than 0. Okay, there are a few things to understand. Actually, these are the things. Let me just write these things in a note. For stationary points or for turning points or for maximum minimum points, okay, maximum or minimum, so all of them have the same indication that dy by dx will be 0. Okay, and using that expression you can find out any of the values for y or anything they're looking for. Wait 1 minute. Right, so now this is one of the point, and whenever it says that your value for y is increasing, okay, so for that value for y is increasing, now like the one in which it was stated over here that y is increasing, this indicates that your differentiation over here is greater than 0. And then for x, or sorry, for if the equation is like y is decreasing, in that case it indicates dy by dx is less than 0. Okay, so these are few points that you need to remember for your classes tomorrow, for your exam tomorrow, sorry. Now another thing to understand, even though this is not with just integration, it is also part of differentiation. For differentiation, if they want you to find out the nature of the turning point, in that case this is how you're going to calculate that or measure that. For that nature of turning point, for this nature of turning point, now you have what can I say? It will be original equation is in terms of y. This is y is equals to the equation, and then you have dy by dx, right? You calculate that dy by dx equals to 0. This will actually give you some value for x. Okay, this will give you a value for x. Like this is the x coordinate of the turning point, basically value for x coordinate of turning point. And after that again, for dy by dx is equals to 0, the value for x that you got, in order to identify if this is the x coordinate for a maximum value or for a minimum value, you are going to input that value of x coordinate, okay, that value of x coordinate into the double differentiation equation. So you are going to input that value for x into the double differentiated equation, and using this, if you can find out if this, use that after inputting the value for x into that double differentiated equation, if this turns out to be positive, then that value was actually for the minimum point, okay, that were for your minimum turning point. and if this one is for that negative one, then this is for your maximum turning point. Okay. These are very, very important things to understand and to remember for tomorrow's exam, because they will certainly ask you at least one question regarding these concepts. Okay, so very important. So I will just draw a box around it. 1 minute. Wait, sorry, 1 minute. Okay, this is a notes. Okay, now we'll move on to your maths. Now we know, since in a question it was stating that y is increasing, this indicates that dy by dx was at an increasing stage over here, right? Another thing to understand from the previous parts, we know that whenever we want to differentiate, this equations has to be written in terms of power, right? So I'll just simplify it. So y is going to be 2 by 3x squared, and then we're going to have minus 9 root x, which is going to be minus 9 x to the power of half and plus 13. So then you have dy by dx. I'll first find out the differentiation over here. Dy by dx is going to be what? 2 will come in front, and then again you have half 9 x to the power of negative half, and the 13 will be entirely vanished this time. So basically you're going to get, and this is obviously greater than 0, right? So basically you're going to get 4 over 3x 9 by 2 root x greater than 0. After this, I will just do LCM over here in order to find out the range of possible values for x, which is basically, if I do the LCM for that 3 and 2 root x, this is going to be 6 root x, which makes this is going to be 4x multiplied with 2 root x minus 9 multiplied with 3. Okay, basic LCM we did over here. And then again you have 8 x to the power of 3 by 2 minus 27 greater than 0, because the denominator becomes 0, right? And again after this, for x, this is going to be 27 over 8, and everything will be on a power of 2 by 3, because now the power will be in an inverted format. 1 divided by 3 by 2 will become 2 by 3, and if you calculate this, you are going to get the value for x as 9 over 4. This is the final range of values for x, that for that 9 over 4. After this part A, again we are going to have that the point P lies on C and has coordinate 940. Okay, they have given you one coordinate now, and the line L is a tangent to C at point P also. The finite region of the of this curve C is on like is represented on the diagram, and you need to find out the graph over here. Okay, now for this part, what will I do is that I will use integration to integrate the equation for the curve. But when you integrate the equation for the curve, this is the total area that you are going to get. Okay, this entire area you will get for that integration of the under the curve. Problem is, I do not want this entire area, right? I only want that shaded area. So I can do another thing. 1 minute. This is the area that I will get when I will integrate the entire curve's equation, but I do not want the entire area, right? I do not want this portion of the area. But I can clearly see one thing over here, that this portion is entirely creating a right angle triangle, right? So if I can calculate the area for a right angle triangle, I will just have to subtract that right angle triangle from that shaded part of the curve, from that yellow shaded part of the curve, or from the total surface area of that curve, and that will also give you the value for my region R, right, which was a shaded region on your question originally. So now I already know upper boundary will be what? 9, and lower boundary over here, this is 0, right? On y-axis, the value for x is 0.
So I can clearly understand. I will integrate the equation for a curve with boundaries of 9 and 0. So let's start the integration over here. For part B, we'll start with the integration, area under curve. This is your 9 over 0 boundary, and the equation was 2 by 3x squared, and then 9 minus 9 x to the power of half plus 13, and then again you have this 2x 2 plus 1, which is 3, so you're going to get 3 multiplied with 3 because that was your new power, and then 9x half plus 1, that is half plus 1 is 3 by 2, so this is 3 by 2, and then again 13x within the boundary of 9 and 0, right? This is your case for integration, and after integration, I'll just simplify it. You have 2 over 9 x to the power of 3, then you have 9 divided by 3 by 2, right? This is going to be 18. 18x to the power of 3 by 2, and then again 13x within the boundary of 9 and 0. And I already know that if I input 0 into the equation, everything will be 0, right? So I'll just input 9 and find out the total area for this part. So 2 by 9, 9 power 3, 18, 9 power 3 by 2 plus 13, 9, and this will give you the final answer for the area under the graph would be 109 divided by 21. Sorry, I think this is, wait, let me calculate it. This is 117 that you are getting for this part, okay? This is 117. Now again, after this, I will calculate the area of the triangle, but then again, area for that area of the triangle, I need to find out that exactly where this line was crossing the x-axis. Since I already know this is a tangent, right? The line over here is a tangent and was crossing through that point 440. I can find out an equation for the tangent. So let's find out an equation for tangent for point P. I already know the expression for your gradient, which this is the expression. 8x to the power of 3 by 2 minus 27. This will give you the value for your gradient, okay? 8x to the power of 3 by 2 minus 27, right? So I will now try to calculate the equation for your tangent. So we're still on part B, and we're now focusing on the tangent calculation. Okay, for the tangent calculation, let's just first find out the gradient of curve, which is dy by dx 8x to the power of 3 by 2. I think it was what, 827, right? And now on this, I'll just input the value for the x coordinate of point P, which was 9. So it will be 8, 9, 3 by 2 minus 27. Sorry, I actually made a mistake. That means we are supposed to use this one. We cannot use this one because it was still in divided format with 6 root x, right? So, I mean, we can use this one. We just have to add over here 6 root x over here in this equation. So I'll just keep using this one, okay? Root x. Now again, instead of writing x, I will just input the value for your x into this expression. So now it will be 9 3 by 2 minus 27 over 6 root 9, and this should give you 21 over 2. That is the value of your gradient. Always remember the tangent and curve are parallel to each other. So if tangent is parallel to your curve, in that case, for tangent and curve, they both will have the same gradient. So for the tangent also, you're supposed to get the same gradient, 21 and half, 21 by 2. So, and then again from this part, we can understand, you can now create the equation for your tangent, y minus 40, then 21 by 2, x minus your value for gradient would be 9, right? If the value for the x coordinate of that point P was 9. So this is y 21 by 2x minus, this is actually 21 by 2 into 9. This is 189 by 2 plus 40. Which is going to be minus 109 by 2. Okay, this is the equation for your tangent. Now after this, part, after using the calculating the gradient of your curve, we will now start doing your area under the graph. Now I already understand that at the point where your graph was, the tangent was meeting the x-axis, the value for y was 0, right? So I can write at x-axis, the value for y is 0. In that case, 21 over 2x minus 109 over 2 equals to 0, which is going to be x 109 over 2 divided by 21 over 2, which is going to be 109. This is 21 by 2. And this will give you 109 by 21. That means the point where your tangent meets the x-axis is actually 109 over 21. This is approximately 5 point something, but we'll try to keep it as this because this is like a more accurate value, right? So let's just go back to your graph again because it will be easier for me to explain from there. Over here, your coordinate is 9, and over here, your coordinate is 109 over 21. And change in y-axis is your height, which is 40 minus 0, that's just 40. And your change in x-axis is your base, which is 9 minus 109 over 21. So in order to find out the area under the triangle, we just have to multiply half 109 minus this entire base expression and the expression for your height 40. So last we will do is the area for your triangle. I'll just have to squeeze this to the right hand side because I do not have much space for this maths. Okay. Now area of the triangle, area under tangent mainly. This is half. Base was 9 minus 109 over 21 and then multiplied with height was 40. So if we again calculate this, now you're going to get a value for 1600 over 21, and finally the shaded region R. For that, you just have to subtract this from your area under the graph, right? 117 minus this value that you got from the tangent area. And this one turns out to be 857 divided by 21. Okay, and that is your final answer. I'll just zoom out so you guys can have a look for this part B. We calculated the area under the graph within the range of 9 and 0, and that turned out to be 117. After that, we calculated the equation for your tangent. Using that, we calculated the base, like where the graph would meet, where the tangent would meet the x-axis, and using this data, we are able to calculate the value for your area under the tangent now. And then again, by subtracting this with your area under the curve, we could find out the area of the region R. Okay. So after that, we'll start with this maths. This is November 2023. Similar part, it has the Karsky-Haas equation where k is a positive constant. We need to show that this can be represented as this, where within the boundary of 16 and 1, you just have to integrate this, and the integration will be in this format where a and b are integers that you have to find. Okay, so you have x minus k whole square divided by root x. 1 minute. X minus k whole square by root x. So let's start. I think it was root x, sorry. So now over here, I will first obviously break down that numerator first using that formula of a minus b whole square. So this is going to be x square minus 2kx plus k square divided by root x. Now using this, I can eliminate, like simplify the denominator. which is going to be x power 2 divided by x power half, and then 2kx divided by x power half, and then k square divided by x power half. After this again we are going to do the same procedure. 2 minus half is x power 3 by 2, and then minus 2k x to the power of negative half, and then k square x to the power of negative half. So this is going to be 1 minus half, so this is going to be positive half over here, right? Yeah, okay, this is correct. Now after this, we'll start the integration process since everything is now written in the forms of power. So integration was within the boundary of 16 and 1 on your maths. So we'll start with this 16 upper boundary, lower boundary 1, and you have 16 3 by 2. I'll just write that detailed information now. I'll not write that x minus k whole square over root x anymore because I simplified the equation in this format, right? So x to the power of 3 by 4 minus 2k x to the power of half, and then k square x to the power of negative half. So from this part again, if I do integration, this will be 3 by 2 coming in front. Wait 1 minute. Instead of 3 by 2, it will be 3 by 2 plus 1, right? So this is going to be 3 by 2 plus 1, which is going to be 5 by 2 at the end. So this will be divided by 5 by 2. Similarly, over here, you have 2k x power 1 by 2 plus 1. This is going to be 1.5 in the denominator. And then again, k square x power negative half plus 1. This is going to be half. And obviously, these were within the boundaries of 16 and 1. After that, we're going to write x to the power of, this one entirely becomes 2 over 5, right? Because your entire denominator gets inverted as the denominator was in the divided format. So this is going to be 5 over 2. Then again, 2 over 3 by 2 turns out to be 4 by 3, k x to the power of 3 by 2. And then again for the last part, this is going to turn into 2k square k to the power of positive half this time. And obviously within the boundary of still 16 and 1. I will now input that 16 and 1 once in every portion of the equation. This is how it will look like. 2 over 5, 16 with a power of, I think this is 2.5, so I'll just write it in decimals. 4 over 3, k, 16 1.5 plus 2k square, 16 0.5, or this is entirely root. And then after this, same expression will be copied, but the value for your x input will be changed to 1. This is 1, 1, and 1. After this again, if you calculate the first part, your first expression is supposed to be, wait 1 minute. Right, that 2 by 3, so 2 by 5 multiplied with 16 to the power of 2.5, that is 2048 divided by 5. And then that 16 to the power of 1.5 is 64 multiplied with 4 by 3, that is 256 by 3k. And then again for that 16 half is going to be 8, not 8, 4 into 2 is going to be 8, so you have 8k square, and then this is actually subtracted from the first expression, right? So this is subtracted, the first one is just going to be 2 over 5, the second noun would now be positive, so it will be plus 4 by 3k minus 2k square, and now we can clearly understand this 8 minus 2 is going to be 6k square, 256 by 3 minus 4 by 3, so minus 256 by 3 plus 4 by 3, which is going to be 84k. And lastly, this 2048 by 5 minus 20 is just going to be what? 2046 over 5, right? That is your final expression. If you go back to your very top, if I go back on this part, you can clearly see everything is similar. In that case, the value for your A turns out to be 6 and the value for your B turns out to be minus 84. So I'll just write it down over here. In that case, A is 6, B is minus 84. So I will just zoom out and so that you guys can have a total look at this entire portion. This was part A. We'll move on to the next part. For part B, it says that there's a graph shown and it says that figure 1 shows a sketch of the curve C and the line L. The line L intersects C at points A. They have given you the coordinate for A and B with 16 and Q, where Q is a constant again. We need to show that the value for K is 4. Okay. Now we can clearly see we have been provided with a point, intersecting point 1 and 9, right? So we can use that to find the value for K. So 1 and 9 is a common coordinate for the line and for the curve. So I'm going to use that 1 and 9 to input in the equation for your curve to get the value for K. So for part B, A has a coordinate of 1 value for x, 9 value for y. The equation was originally x minus k whole square divided by root x, which is now going to be 9, the value for y, x minus 1 whole square divided by root 1, which is just 1, right? So you're going to get x minus 1 whole square equals to 9. Now if we take this square to the other hand side, this will become root 9. In that case, the value for x is either 9, when root 9 is just going to be 3, 3 plus 1 is 4. Not exactly x, this is the value for k. This was actually, sorry. 1 minus k. Sorry, I actually made a mistake. 1 minute. So 1 minus k whole square, 9. This is going to be now 1 minus k root 9. This is 3. Wait, 1 minute. Was the value for k 9, 1 or minus 1? Let me just check. No, it was 1 and 9. And that was x minus k on your equation also. One minute. We need to show the value for x is equals to 4. Maybe it's on this basis that after the square root, the value that you're going to get is either plus minus 3. According to that, 1 minus k equals to minus 3, that is one of the possibilities, and 1 minus k is equals to 3, which is going to be 1 minus 3, 1 plus 3 is equals to k, which will lead you to the value for x equals k equals to 4, and 1 plus, this is going to be 1 minus 3 equals to k, that will lead you to the value for minus 2, right? So we cannot accept this one because k was greater than 0. So we'll only accept the value for k is equals to 4. That is the only basic definition that I can provide why the value for k is 4 over here. After that, we'll move on to part C. The region R shown shaded in figure 1 is bounded by curves C and L, and using your answers to part A and B, find out the exact region B now. Okay, now in this situation, now they're asking you to find out that the area under the graph from B and L. Okay, for that B and L, we can find out, for example, if I can draw a straight line over here, this one and this one. Right, we can clearly see this entire region is actually creating a trapezium, right? So we can calculate the area of the trapezium and then subtract your area or under the curve from it to get the shaded region, right? Because area under the curve will actually give you these portions. These portions will be given by your area under the curve. So we can easily get that by subtracting area under the graph from your area under the trapezium, because using that straight line tangent or line L, that is actually creating a trapezium with your x-axis. So trapezium minus area under the curve, this yellow region will give you the shaded region R. So again, one thing, I already know I do not know actually the value for this q, and I need to know that because it will be needed for the height of your trapezium, because on trapezium these two are parallel. Now I know this one is 9, but this one is q. How much is q? I do not know that. And then again, this is 9 and this was 16. That means changing height over here is actually 16 minus 9, which is 15. Right, height is 15 of the trapezium, that is okay, but I need to know that value for q. I can find out the value for q by substituting the line into the equation, or wait, I can just substitute 16 into the equation for the curve, and that will give you the y coordinate for that point B, because point B is again a common point for the curve and for your tangent, for your line, in this case line L. So for part C now, for point Q, B has a coordinate 16 and Q. In that case, y is equals to x minus k whole square root x. Now I know the value for k was 9, sorry 4. So instead of writing y, I'll write the y coordinate of point B, which is Q, and this will be 16 minus 4, everything under a square, root over 16, which is, this is now 36. Now I know the height of the trapezium was 36. So I can easily find out the area. Since I do not have much space, so I will just try to squeeze all these things in one part. Okay, now after this, for this A, B, and C, I'm going to calculate the area under the graph. After that, this is how the working would be. For your area under the graph, the boundaries should be 16 and, sorry, I'm actually, maybe I'm making a mistake over here. Wait 1 minute. Yeah, this is actually the y coordinate over here was 9. X coordinate over here was 9. Sorry, 1. So made a mistake over here doing this calculation. 1 minute. Let me correct it. This was 16, this was 1. So height over here is actually 16 minus 1, that is 15. Right. Now after this, we will calculate the area for the shaded region, which is basically what? Trapezium minus that area under the graph, right? For the area under the graph, I already have calculated the expression, right? This was the expression. I just have to input the value for k, and that will give you the value for your total area under the graph, because this was also within the range of 16 to 1. So we did the integration at the very start. So for area, this is how we'll start. Half, parallel sides were 9 and 16, so 9 and 36, multiplied with height 15, and after that you have the area under the graph as 6k square, so 6 4 square plus, I think it was minus 84 4, and then 20 46 and 5, right? So if you calculate all these things, the final area of that shaded region turns out to be 1683 by 10, and this is your final area. If I zoom out, this is the entire working for the part C. I hope part C was clear for all of you. We'll move on. Okay. Now this one has this solution for this, and it says that the curve C with equation y is equals to x square minus 4x plus 5, and the line with equation y is equals to 2, they both intersect at point D on the y-axis and write down the coordinates of D. I can clearly understand on y-axis, right, with line with equation this intersects the y-axis at point D. 1 minute, this is your x-axis. I mean, at point D, your equation will have 0 x-axis, right? The value for x is 0 at that point. So if the y is equals to 0, then I can write the y is equals to 2. The line with equation 2, y equals to 2, right? 1 minute. I mean, at y-axis it's just 0x. So it's just going to be 5 over here. I'll write down the answer for part A. So y is simply going to be 0 square negative 40. This is just 5 over here. Okay. Now after this, now I know the coordinate for point D, 0 and 5. Okay. Now after this, it says that curve C intersects the line L at point E and F, and find the x-coordinates of point E and F. I already know, since they're intersecting with the line y is equals to 2, they're both going to have the coordinate y equals to 2. So I just have to factorize this time. So at this part, for part B, at y is equals to 2, I already know y is equals to 2, right? So which is going to be x square, I think it was minus 4x plus 5, sorry, plus 5 minus 2, which is going to be x square minus 4x plus 5 minus 2, 0, x square minus 4x plus 3, 0. So now I'll just have to middle term this, x square 3x x 3, 0. So x minus 1, x minus 3, 0. So the value for x is actually 1 and the value for x is then 3. Okay, so now these are the coordinates for your x-axis. After this, these are the values for E and F also, right? Now we have the coordinates for E and F. From your graph, you can understand which one will be before and after. E was before and F was after. So in that case, E will have the 1 coordinate, 1 and 6, so 1 and 2, and F will have the 3 coordinates, 3 and 2. Okay. Now again, after this, if you go back to your graph, it says that the region R is bounded by C, L and Y axis, and region 2 is bounded by C, line segment EF and DF. We need to find out the ratio for R1 and R2, which is represented as K. You have to find out the value for K using integration and all that. Okay. Now you can calculate that easily. For example, 1 minute. This time over here, the integration is not actually with respect to x-axis, this is actually with respect to y-axis over here, right? So one thing I can understand, this total area is at triangle, right? So I can find out the area of the triangle easily. And after that, if I can only find out this area, this region, which is basically the area under the graph between the points D and the y-axis of point E, which is y is equals to 2, right? And that will be it, right? After subtracting the total area, after subtracting R1 from the total area, we can get R2 also. So let's just start with our working and it will be more clear as we go on. So let's just first find out the actual area for this case. Point D was at point 5, this was at 2, and F was at point 3. That means base over here is 3, height over here is also 3. 5 minus 2 is 3, right? This one is 3 and base is also 3 because over here at this point, your x-axis is 0. So 3 minus 0 is 3. So I can find out the total area, which is R1 plus R2 is half into base into height. 3 into 3 is just going to be 9 over 2, right? So I will just write your answer over here for part C. Area for R1 plus R2, this is the total area. So half 3, 3, which is just 9 over 2 unit square. Okay. Now this is your value for the total area. Now we will use the integration to find out the area for the graph of region R. Now region R was within the boundary of 5 and 2, right? So we can do the integration for that easily again. So area of R1, that is basically within the region of 5 and 2, x square minus 4x plus 16 which is x cubed by 3, 4x squared by 2 plus 16x within the boundary of 5 and 2. Now then again, if you do the integration entirely by substituting 5 and 2 into your expression, I am not actually doing that. So, I mean, you just have to substitute 5 and 2 into your expression. So just going to be, just 1 minute, 5, 2, x square minus 4. Sorry, made a mistake. This was 5, not 15, not 16. This was 5. You are going to get 12 over here. Okay. Now for that ratio, I mean, this is still R1, right? We have to calculate R2 also. For that R2, that is basically 9 over 2 minus, wait, 1 minute. If this, wait, 1 minute, maybe I'm making any mistake because the area under the entire graph turns out to be very small. If DF is entirely, yeah, DF is a straight line, this is a straight line. Wait, 1 minute. No, wait, no, this is correct. And we did the integration for, yeah, I actually made a mistake. I was supposed to take the boundaries of 0 and e for R1, right? Not 3 and 5 and 3. I don't know why I took that. Sorry for that. Really sorry. Let me just go back and clear out my mistake. The boundaries should be 3 and 1. So it's 1 and 0. 1 and 0. Really sorry. 1 and 0 because we are basically finding out R1 which was between the y-axis and point E, right? So this is supposed to be 1 and 0 and that will give you an approximate value of 19 by 6. Sorry, yeah, 19 by 6. That is supposed to give you 19 by 6. Oh, wait, 1 minute. Let me just calculate this. 1, sorry. This is supposed to give you 10 by 3. Now I can calculate R1. R1 is basically R total. Like I can calculate R2, which is basically total minus R1. So 9 by 2 minus 10 by 3, which is 7 by 6 now. For R2, this is 7 by 6. For that ratio of R1 over R2, I can calculate that easily. Wait 1 minute. Wait, another thing over here, the final area for your integration will also actually be a combined equation. For that combined equation, this is how the equation will actually be. For curve equals to line, like this is how the equation is supposed to be. That x square minus 4x plus 5 equals to 2, which is going to be x square minus 4x plus 5 minus 2, 0. Because for that region R, it was actually in between that y equals to 2 also, right? Y equals to 2 was also like, limiting that region R over there. So we have to take that into your consideration. So this is going to be x square minus 4x plus 3 equals to 0. This is the final expression. In that case, this one over here is going to be 3. So this is 3x within the boundary 1 and 0. I can do one thing. I will calculate region R a bit lower and I will substitute this in between the working, right? So that we got the calculations of how we calculated your value for your case. And then again, the answer would actually be different now. The answer over here is for R2 is going to be 19 over 16 now. This is R1, R1, 1. Wait 1 minute. R1 is 4 over 3 now. Okay, so for 4 over 3 again, we can calculate 9 by 2 minus 4 over 3, this is now going to be 19 by 6, right? And now I can find out the ratio for R1 over R2, which is 4 over 3 over 19 over 6, which is going to be 8 over 19, right? This is the final ratio for R1 against R2. So this was it for your
P2, all the questions I could complete before the exam. I hope your exams are going to be great tomorrow and the question turns out to be easy. Thank you for watching. Bye bye.